So thank you for joining us on this December webinar. This webinar is an ISV webinar with our partner Net Insight. Today we'll be showcasing a new product called FileTeleport, which has been developed by Net Insight and uses the Falcaos acceleration technology. The webinar will discuss how you can accelerate file transfers with a software-defined media network. We'll be monitoring our Twitter feed. You can tweet us using the hashtag FileCatalyst A bit of an introduction. My name is Elton Carneiro. I handle ISV integrations here at FileCatalyst, as well as I'm a channel manager. And with me today, we have Alexander from Net Insight. Alex, over to you.
Yeah, my name is Alexander Sandstrom. I'm a strategic product manager at Net Insight. I'm working with all of our SDN related solutions, including our new solution, as Elton pointed out, our FileTeleport solution, where we do file acceleration and file transfers using software-defined networking technology.
Great. And thank you, everyone, for joining us today. It's a pleasure having you around. And so a bit about FileCatalyst. So FileCatalyst was founded in the year 2000. We started doing web-based file transfer tools, to our web applets, and then we moved into accelerated file transfer in the year 2004. And since then, we had the FileCatalyst product line. It's been around for about 11 years. And what we do is we provide enterprise-grade software to companies and people looking to move large data around the world. It's a flagship, award-winning product. We've received an Emmy for our technology. It's also a patented, algorithm that allows us to use a unique UDP-based approach to transfer large files over the internet. We simplify complicated, large file transfers for the enterprise, end users. We have a very simple, interface that allows you to, transfer files, from your desktop, from a web browser. If you want to integrate into other applications, we have tools that allow you to do that. Falcaos also provides you all the management, security, and monitoring tools to ensure the data is moved efficiently, securely, and reliably across your corporate network. We're available on major cloud providers, including Amazon, OpenStack, Windows Azure, and so on. Next slide. Some of our customers in the media and broadcast space, we have NBC Sports, Sky Sports, Sony Pictures, and so on. FileCatalyst is a very horizontal application. It can be used in any vertical, media and broadcast being the main one, but we also can be used in oil and gas, corporate, IT, financial, medical, and so on. At this point, I'll let Alex introduce Net Insight.
Yes, so for those attending the webinar who has not heard of us before, I'll give you a brief introduction. So what our core business is media transportation and media transport. We have a broad set of solutions that goes beyond that, really touching all the parts of the value chain from glass to glass in media production, including workflow and orchestration, as well as live OTT distribution, which is a newly launched solution from us. But again, the core and the foundation of the company is media transport solutions. And we try to deliver experience that audiences want to be part of. We help our customers do that. We help our customers take media content from stadiums, studios, and live events all over the world. And with on-demand connectivity, where our customers need it, when they need it, we help put them in control. So this is a tie to SDN, and we'll get back to SDN and the details there. But that is a foundation of the company, providing that live media transport with on-demand connectivity. We have a broad set of customers. We today have over 500 customers in the media space. This is a selection of some of them, as you'll see on the slide. If you recognize some of the names, we have everything from large service providers that have global service provider networks, all the way to broadcasters, media producers, post-production companies, etc. So a large set of customers in the media space, again, helping them with transporting content, but also managing their workflows, scheduling and orchestrating those workflows, and distributing live video over the top of the internet. So that was a brief introduction to Net Insight. So before we take a look at the solution that we have developed together and the focus of that, and give you a bit of a demo there, I just wanted to touch upon a few things when it comes to file transfers, as well as a very quick 101 on SDN. So file-based media production is nothing new. Everybody knows that the broadcast-based media producers are quickly moving to file-based content or file-based workflows, and with that file-based content acquisition. We here on the left-hand side of the screen see a survey from Devoncraft this year, which says a couple of things, but one of the things that I wanted to highlight here was that even for time-sensitive media production, news being the example in the survey, we see that that is moving more and more to file-based operations. So as this survey shows, in just a few years, pretty much all news production will be file-based. So if that means that we're going to file-based workflows also for time-sensitive media production, then we run into the challenge of how do we move content across networks fast. If we want to put file content on a VOD store a week from now, it's not time-sensitive. But if it's for a newscast going out on air in just a few hours, we suddenly have a time-sensitive, or which is sensitive to time of that transfer. So how do broadcasters and media producers solve that? Well, internally, they can rely on proprietary software to some extent, together with leasing point-to-point connections between, if they say have two studios that are interconnected, there can be a static link between those. But for content exchange with others and to acquire content from multiple different locations, many revert back to inefficient protocols such as FTP to do these type of transfers. And the only way you can handle the time-sensitive exchange is by getting dedicated lease lines and special software on top of that. So you limit the reach and you limit a lot of the flexibility in that if you have to lease dedicated lines to each and every location where you want to do transfers, you're severely limited. So you see a bit of a problem in the market when it comes to these more time-sensitive media production and getting those to be more flexible and support faster file transfers. So one of the key technologies helping us to solve this problem is software-defined networking. And there's many definitions of software-defined networking. You can get very academic about it, but on a very high level, what we talk about when we talk about software-defined networking is a network, a managed network that is programmable, that typically has centralized control, and where network connectivity is steered by business applications and business logic. So any type of application you want to run on top of the network can program and control the network the way it needs to fulfill its requirements. And why do you want to do this? Why do you want to let these applications drive the network? Well, it's really a foundation for delivering bandwidth by the minute. So instead of having static connectivity in a network that you set up for months or even years, you can suddenly now deliver services and bandwidth by the minute in a network. And you can also, on top of that, speed up new services time to market. So once you have a network that is software defined, where an application sitting on top of the network can control it, it's much easier to provide new services on that network by simply adjusting and reconfiguring those applications controlling the network. So what does this mean for the media space and for people in the media industry? Well, the producers of content, the broadcasters, they are really in control. If a service provider or themselves have built a network that is software defined, you put the end users in control of connectivity. So you get connectivity where and when it's needed, and in a service provider relationship, you actually pay only for what is used. So instead of buying connectivity for a month or a year, you just do it for a period of time you need it. That could be minutes, hours, days, but there's a lot of flexibility in that. So we see that the media production workflows are getting more and more automated. There's a drive to make media production workflows a lot more agile, and software-defined networking helps support that with real-time and on-demand network connectivity as opposed to very static and rigid network connections. So that was a bit of a one-on-one on software-defined networking before we go into what the solution actually looks like. So on a very high level, what our FileTeleport solution is about, it's about transferring files using on-demand bandwidth. So as a user, and I'll show you a quick demo in a bit, as a user, you simply select what files you want to transfer, what destinations you want to send those files to, and you decide when the files to be there. So tying back to what I said previously about time-sensitive content, you can now suddenly say, this piece of content is very time-sensitive, I need it to be transferred fast, versus another piece of content that is less, where the transfer is less urgent, and then you give that less capacity and bandwidth throughout the network. The user doesn't need to care about networking and bandwidths and capacities, they only care about their files, the destinations, and the arrival time. On top of the solution automatically setting up all connectivity that is needed, the end users are in control of the cost of doing the transfer. Again, if it's a broadcaster and service provider relationship, the broadcaster and media producers and post-production companies can pay per gigabyte of transfer data. They can pay less if it's not urgent, pay more for an urgent transfer, etc. But you get real-time pricing information when you do the actual transfer. And finally, the solution also gives you the possibility to do this with guaranteed arrival times. So compared to using, say, public infrastructures like the internet to do file transfers where you only get an estimated time of arrival, here we guarantee bandwidth, and by doing that, we also guarantee time of arrival for the file transfers. So a summary on why FileTeleport. Well, with FileTeleport, broadcasters, content owners, media producers can really accelerate file transfers and get guaranteed time of arrival. So the whole platform is actually interoperable. So Elton mentioned initially that we are integrating FileCatalyst software into this, but all interfaces outside of the platform are standardized. They could use NFS or SMB or any other file transfer protocol that is standardized to connect into file storage. And we use file acceleration software across the wide area network to accelerate transfers over longer distances. So the platform is interoperable. Everybody connected to it can exchange content. And really, as a user of the platform, you don't need to manage servers and software. You don't need to know about server addresses, ports, user credentials, etc. All of that is managed by this platform that you'll see in just a second. So there's three main key benefits that we want to highlight here then. That first of all, using this software-defined network technology, we automatically set up on-demand bandwidth, and with that, we truly accelerate file transfer. So for a really urgent transfer, you can set up 10 times as much bandwidth or even 100 times as much bandwidth as you would typically have in place for that transfer to really speed it up. So again, you also get guaranteed time of arrival, so you get a lot of predictability into your production workflows. You know when the files are going to be there, there's no estimates, and you need a lot less margin in the production workflows for the actual transfers. Finally, if you're a service provider offering this type of solution to your end users and your customers, you also get an automation that doesn't only set up connectivity and transfers files, but it also ties into a billing system and a pricing engine. So the entire solution encompasses also pricing capabilities where you can price out the service and price out connectivity differently depending on location, time of day, different discounts for different end customers, etc. So let's look at the solution and what it looks like from a user perspective. There's a lot of different perspectives you can take. Of course, there's an operator having to manage the solution, etc. But let's look at it from an end user perspective. It gives you a good idea of the flow throughout the application. So I start with a login screen. Of course, every user has their own ID, and that controls what files they have access to, etc. So I sign in, as you might be able to see here. This is an iOS demo, so I have Touch ID, etc. Supporting me here, but there's different possibilities to use different front ends, obviously. Once I've logged in, I'm, as a user, presented with a list of files. So the solution is connected to a storage area network or a network-attached storage. On that, I will now see what files I have access to. So I get a file list, I can browse the directories, etc., just like I would on a normal computer or any other type of file transfer solution. So this is pretty basic. What I do here is I select the files I do want to transfer. I see some status in terms of selected files, file size, etc. Once I've identified the files I do want to transfer, I click the next button down here, and what that does then is it takes me to the next screen where I select destination. And as this is a managed platform where an operator of the platform would set up all the user accounts and all the rules behind it, I only see the destinations that I'm actually allowed to send to. So as an end user, if I'm only allowed to send to a handful of locations, those would be the only ones showing up here. So I don't need to, as a user, understand where I'm allowed to send to. I don't need to remember addresses, etc. All of that is just showing up automatically here, and I just pick one of them. So if I pick a channel here, I'm moving on to the next screen, and this is where we have the tie to the software-defined network that I talked about previously. So what I see on this screen now is a summary of what I'm about to transfer. I also see the time of arrival for the transfer, and this is showcasing a use case where I, as an end user, would be paying a service provider to move those files across the network with on-demand bandwidth. Bottom part of this screen, you see a slider. And what I can do here is I can, as an end user, say this transfer is urgent, or I can wait a bit longer. So we see that it has by default selected the as soon as possible mode. What it does with that as soon as possible mode is it looks at the total amount of files that I'm about to transfer, the date that I'm about to transfer. It asks the network how much capacity is actually available at this point in time to do the file transfer. I know the source I'm sending from, I know the destination, I selected that on the previous screen, and I now also know how much bandwidth is available. And using that, the application calculates how fast can I possibly get the files to the other end if it's really urgent. That is the as soon as possible mode, and we see here that I'm getting a transfer time of 5 minutes. If it's not that urgent, I can just slide the slider over to the guaranteed time of arrival part of it. And here I can slide it around depending on how fast I need the file to be there. Maybe 5 minutes is faster than I need it to be transferred. Maybe I want it there in 10 or 15 or 20, and I can slide and change the slider accordingly. The guaranteed time of arrival on top of the screen will be updated. The price point and the estimate will be updated. And I can then, as a user, decide myself, is this urgent? Is it worth paying extra to get it there, or is it not? I can slide the slider all the way down to a best effort transfer. It will obviously take a lot longer, but the cost of it is going to be lower. And again, we have a pricing engine tied to this solution. So as a service provider or as a broadcaster doing maybe internal billing, you would be able to set different price points. The example here shows best effort transfer being free, but that is definitely up to the users and the owners of the solution. So once I've now selected the transfer mode, I can just click next. I'm presented with a summary of the transfer before I confirm it. I see the files I'm about to transfer, transfer speeds, time of arrival, the cost. And as a user, I get to confirm this as there's a cost involved. Once I do that, the transfer is added to a status list. Of course, the user can keep track of ongoing transfers. You can see the percentage of the transfer, how many minutes there's left. You can cancel ongoing transfers, etc. And finally, there's also history tabs. You get an overview of what you have transferred before, what transfer modes you selected, file sizes, etc. So the user experience here is really simple. Again, as I said before, the user simply picks his or her files, destinations, and decides how fast the files need to be there. And the underlying system takes care of the rest. So it's, from a user perspective, something very simple, but underneath you have something extremely powerful, giving users complete control of the network and of their file transfers. So that was the solution on a high level, and that is what the users see, and that is the overall experience. But let's now look at how this is actually realized, so you get an idea of the underlying components and how the solution functions and fits together. First of all, there's a number of different components in the solution. We have a front end the FileTeleport application. As I mentioned before, you have the iOS application here as one example, but you could pretty much use any type of front end you like on top of this. We have a FileTeleport backend that holds the logic in terms of setting up connectivity, doing the file transfers, monitoring the transfers once they're up and running, etc. So the application ties into the backend. Under the backend, we have a system called Schedule Link. This is a scheduling system keeping track of all the resources in the underlying infrastructure. That includes network links, network ports, capacities available, etc. And Schedule makes sure that whenever you actually start making a transfer, you reserve bandwidth throughout Schedule and you avoid conflict. So Schedule is what's helping us understand how much bandwidth is actually available before I start the transfer. Schedule also makes sure that there's not going to be any conflict if you try to do 2 transfers at the same time or multiple transfers at the same time. They won't be able to use up more than the available bandwidth. We then have our Nimbra SDN controller. That's our software-defined networking controller, actually executing the provisioning requests from Schedule's link system. So the Nimbra SDN controller interfaces the infrastructure layer. It interfaces the networking nodes to set up connectivity throughout the network. And it's then, of course, monitoring those to make sure there's no issues with the network. And if there's any failures or any issues with the underlying infrastructure, that's reported all the way back up to the application so that the user won't be able to maybe use up all the capacity that they expected, etc. Finally, we have an infrastructure layer here that is made up of from Net Insight's Nimbra MSR portfolio. So these are Nimbra MSR 600s from our 600 portfolio that are setting up the network connectivity throughout the network. They are also running software from FileCatalyst. And Elton will get back in just a second on the details of what components we're running and how that fits together. But the FileTeleport backend is what's controlling this software. It's controlling the infrastructure, and it's tying the whole solution and system together. So the steps that we saw before was, first of all, the user selects files, destination, and time of arrival in the application. That information is then passed on down to the FileTeleport backend. The backend receives that information and looks at it and communicates with Schedule to request on-demand bandwidth. So if I, as a user, said I want this file to be there in 5 minutes, the backend is going to request a lot of bandwidth from the network and from Schedule Link. If it's a less urgent transfer, a best effort transfer, the backend, of course, will request less bandwidth. So the backend takes the information from the user, translates that into networking information so that the user doesn't need to know and care about networking. That is sent to the SDN controller by Schedule's link system. The SDN controller then pushes that out to the infrastructure, and this is where we start to set up connectivity throughout the network. So once this step is done, we have a connection all the way through the network from the source destination, from the source to the destination where we want to do the file transfer. As a last step, the backend tells the FileCatalyst software to initiate the transfer. And that transfer is being made from, as you see on this high-level picture, between 2 locations. In those locations, you have, as I pointed out before, network-attached storage. So the file transfer software is reading from a local disk or a local drive connected to the local network and sending that across the wide area network where we have this connection set up throughout the Nimbra MSRs. So that was the high-level components. And Elton, maybe you can take over and tell us a bit about the underlying file transfer technology.
Yeah, thanks, Alex. For all of that. So, one of the things you mentioned, as you're going through your slides, is, with Nimbra, you can allocate bandwidth, and that you're guaranteed that bandwidth. So, I guess one of the good things with your technology is that you eliminate packet loss on that link. So there is no packet loss. Whatever bandwidth you get, you have it. The problem comes when you're looking at latency. So if you go to the next slide, we can talk about and seeing how latency affects transfers. So one of the things you mentioned is one of the tools or solutions currently being used is FTP. FTP is a very serial process. Each packet of data is sent and has to be received on the other end before more data is sent. So the problem with latency is that this is the distance or the time it takes to transfer a packet from one point to the other and back. So the further away you are, the longer it takes to send this. And there's nothing you can do about that. That's just the way the internet works. So with that being said, the further apart you are, the longer it takes for FTP to transfer this file. Looking at FileCatalyst, we're immune to latency and packet loss. In this case, packet loss is not an issue. So however, since we're immune to latency, since you are allocating that bandwidth, we can guarantee using our technology to make sure we're fully maximizing that link. So what we do is we basically break down the file into multiple blocks and concurrently transfer multiple blocks, and we'll only acknowledge packets that are missing. So opposed to acknowledging every single packet, we do a negative acknowledgement, so only packets that are missing will be requested and retransferred during that time. So if we go to the next slide. So how do we do this? So it's a UDP-based protocol, which has a proprietary retransmission and congestion control. In this case, congestion control is not applied because there is no congestion. Since the link is available, we'll maximize it. We started the link speed, and we'll continue transferring the file, using that speed throughout the entire transfer until the transfer is complete. It's a patented algorithm, so it's built from the ground up in-house. We can transfer up to 10 gigabits per second with encryption using any commodity hardware. And this is one of the things that, with Net Insight and Nimbra boxes, we're able to deploy our technology and be able to maximize 10 gigabits without any additional hardware being, required. We're not affected by latency and with linear packet loss, and we can leverage a multi-core CPU architecture to ensure that you're fully maximizing your link, even when you're using encryption. So next slide. Yeah. So this slide will show you how we compare against FTP. So we have two scenarios here. One is a 1 gigabit connection and the other is a 10 gigabit connection. So we're going to go show you how latency affects FTP transfers, how we're immune to the latency factor here. If you look at a transfer from Amsterdam to London, you have about 50 milliseconds of latency. To transfer a 10 gigabyte file, FTP will take about an hour and 28 minutes, whereas FileCatalyst will take 1 minute and 23 seconds on that 1 gigabit connection. Looking at a transfer from New York to Buenos Aires, you're looking at an RTT of about 150 milliseconds. To transfer the 10 gigabyte file, FTP will take 3 hours and 6 minutes, whereas we will still take 1 minute and 23 seconds. Looking at a longer distance, you're looking from LA to Mumbai, the latency is about 220 milliseconds. To transfer a 10 gigabyte file, FTP will take again about 3 hours and 22 minutes, whereas FileCatalyst is immune to that latency and will still transfer the file in 1 minute and 23 seconds. Things get a lot more interesting when you have a 10 gigabit connection, whereby we can transfer the same 10 gigabyte file in 8.4 seconds, regardless of how far the two endpoints are. So going back to what Alex was showing you, looking at FileTeleport, where you can actually select, the time you want to take for the transfer. It's all based on how much bandwidth you allocate to that transfer. So in the case of the as soon as possible mode, whereby it's in 5 minutes, you're allocating more bandwidth, and we're able to maximize all that bandwidth. Whereas with the best effort, you're allocating less bandwidth or using FTP as a protocol or a slower bandwidth, whereby it takes longer, and so on. Next slide. So what are the underlying Falcaos components used in this solution? So the product that was used is FileCatalyst Direct. So FileCatalyst Direct is our point-to-point file acceleration software. It requires our software to exist at both ends. It's a server-client model. The server sits in a central location, and the client can be deployed in the field. In terms of client applications, we have a number of applications. The hot folder does automation, so you can automate transfers and have it run as a background, monitor your folders. As soon as content becomes available, we transfer it. We have a desktop client called Express, which allows you to perform ad hoc transfers. We have browser components that allow you to perform transfers from a browser, as well as we have mobile clients and an SDK. So looking at the next slide, the main client application that has been used in the FileTeleport solution is a Falcaos transfer agent. When we first developed the transfer agent, it was an alternative to web applets. So this was basically replacing our web applets to allow people to do transfers from the web browser. We then realized that since this is an agent that's running on a machine, we can actually make remote calls to it. So this is when we started exposing our full REST API to be able to instantiate transfer from remote locations, be able to get statistics, cancel transfers. And this is how we decided it'll be a great tool to use in the FileTeleport, whereby you have a central location trying to control transfers across an entire deployment. The transfer agent can be integrated into any application and using any programming language, because it's fully REST. So if you understand REST, it's all over HTTP. So pretty much any, from scripting languages to applications like Java, C++, C Sharp, any language can interface with our FileCatalyst transfer agent using our REST calls. So let's take a look at the next slide. And the last component was the FileCatalyst Central. The FileCatalyst Central is an application that allows you to sort of basically have a bird's eye view of your entire deployment. So you can see all the transfers are happening in real time, what nodes are connected, what nodes are done, and so on. So this tool also has a full REST API that we're able to pull all the archive transfers that have happened, drill down to a specific node, change the bandwidth, change priorities, and so on transfers as they're happening in real time. It also, has the ability to trigger alarms in case a node goes down, in case a transfer fails. We get notified of all these events. So let's go to the next slide. So back to you, Alex.
Yep. So you've now seen some of the components involved, but if we look at the bigger picture and some of the key takeaways of the solution as such, using file acceleration, or rather file acceleration that is using a software-defined media network and that on-demand bandwidth that we talked about, really give broadcasters and media producers fast and reliable file transfers. And it gives network service providers a new offering so that they can climb the value chain. If you, as a service provider, introduce this type of offering to the market as a service, it suddenly complements live video services, audio services, and Ethernet services as a higher value service. The FileTeleport solution as such truly accelerates file transfers. It does that bandwidth, and it does that using FileCatalyst software and acceleration technology. It guarantees time of arrival of all the file transfers. And as pointed out before, it also automates not only setting up connection and doing transfers, but all the way to the bill. So it simplifies usage, and it really keeps operational costs low when you automate that whole chain. There's no manual work involved. From the second the user touched the transfer button, everything is automated all the way to the bill. And finally, it lets you combine live and file-based workflows in one infrastructure. So as I said initially, one of Net Insight's core aspects and core parts of our business is media transport, and especially of live content, where you have very demanding and high quality requirements. So if you start adding file-based and file transfers onto that type of infrastructure, it's important that it allows you to combine those with live without affecting the characteristics of the live services. So as one final note on this, we showed you the quick demo. I think one of the most powerful aspects of this is that for the user, for the end user, this is a very simple experience. They pick the files, they pick the destinations, and they pick the time of arrival. They don't need to understand file acceleration software. They don't need to worry about how FileCatalyst works technically. They don't need to know about networking. They don't need to understand bandwidths or software-defined networking. All they know is files, destinations, and time of arrival, and the system takes care of the rest. So with that, we're through with the overview of the FileTeleport solution and of how file acceleration using software-defined media networks is taking file acceleration to the next level. So we now have time for a Q&A. Me and Elton will stay on the line for a bit. So if you have questions, please feel free to send them in at this point.
Yeah, thanks, Alex. Yeah, so if you have questions, there's a question panel in your GoToWebinar control panel on your screen. Feel free to type that question in. As we receive the questions, we'll read them out so that everyone can hear the question. And depending on the question, either myself or Alex will answer it. Yeah, great. So we got our first question. Question is, how can you guarantee that file transfers will not impact live traffic in the same media network? I guess
Yeah,
Alex, that
so
would be for you.
yeah, I can pick up that one. So we have multiple solutions or multiple components to that solution. So first of all, the infrastructure that we are building this solution upon, the Nimbra MSR platform, actually guarantees service characteristics. So once you've set up a service, whether that's a live service or a data connection or a file transfer, once that is in place, the characteristics of that service will remain the same, whether you keep adding new services parallel to it or removing services. So the dynamic behavior of a software-defined network will never impact the services that are deployed in the network. So, and that is on the infrastructure layer, with the nodes guaranteeing bandwidth and guaranteeing quality and characteristics of all services. On top of that, the schedule system that I mentioned before that reserves capacity and bandwidth will do that in a way so it makes sure that you never ever over provision your capacity. So if you have a live service set up, the ports for that, the bandwidth, the connection is reserved so that will never be affected once you start adding in file transfers. One of the things I pointed out before was the FileTeleport. The first thing it does once the user has selected files and destination is to check with the network how much capacity is actually available between A and B. And that becomes your as soon as possible mode. So it knows how much bandwidth is available in the network. And it does that based on schedules, scheduling, and resource handling capabilities.
Cool, thanks. Yeah, and I guess there's another question. Can I address destinations outside of the Net Insight network and use file acceleration? I guess that one's for you, Alex.
So sorry, Elton, I think you're cutting out there. Your voice is...
Oh, they go into robotic mode again?
Yeah, this is better.
Okay, so yeah, so the question was, can I address destinations outside of the Net Insight network and use file acceleration?
Yeah, and I can add into that. So absolutely. So the solution as such and the value adds you get of on-demand bandwidth, as we talked about here, obviously requires that you have a managed network where you can control and set up connectivity. But as we're using the standard FileCatalyst components, you can tie in any FileCatalyst client into this. So you can have some clients coming in over the internet and some coming in through the managed network as such. So the fact that we use the components from you guys that are coming off the shelf means that we the solution pretty much support any type of client that you have in your portfolio.
Cool. And another question is, do you expect a mix between internet and leased lines in the infrastructure?
Well, I think we do. But having said that, I think one of the key points and the key benefits of this solution is the fact that it has good support for these more time-critical and time-critical transfers. And of course, the only way we can support them is to then set up this bandwidth. And the only way we can guarantee time of arrival is to know how much bandwidth we set up. So for these time-critical transfers, whether it's news or just something for tonight's show or whatever it may be, where you have something going on air fairly soon, we believe that that's going to be mainly happening over managed networks. And we see that already today, where, as I pointed out initially, many of our customers, and I understand many of your customers, also lease dedicated and static connections to do file transfers from selected events or selected locations. So internet is a complement to that for certain type of file transfers, and we can tie that into the solution. But the key benefits and the values you get out of using a managed network really comes into play when you have these time-sensitive transfers.
Yeah, and that's true. With the not being able to guarantee what's going on internet can impact the file transfer that are happening. Yeah. So there's another question. It says that you mentioned that the solution is tailored towards media producers and network providers. In what way you think the solution is applicable to video delivery platform providers such as IPTV/OT-TV platform providers?
So you can use the solution for many aspects, and I think that's a very good question. So one of the discussions that we have had with a set of our customers is how does this complement OTT delivery as one example, where you have to distribute your content to a large set of CDN servers for distribution and for scalability. And then, of course, this solution would allow you to move files very quickly into your CDN solution and architecture. So there's a lot of applications that comes in on top of this. Any application benefiting from fast file transfers and from more of an on-demand architecture where you're not restricted to just a few locations where you have static connections would benefit from this type of architecture. So there's many applications. Service providers running this as a service is one. Broadcasters using it internally to move files around between locations is one. Broadcasters and post-production companies exchanging content on this type of platform where one or multiple broadcasters content from each other, where post-production companies are part of the production value chain and move raw content and produced content in and out of their facilities is another use case. And again, also for OTT delivery, moving content into a CDN or into a playout facility even is definitely another use case. So there's many applications where this service would provide advantages over what's on the market today.
Thanks. Yeah, and one of the questions is, how does the solution guarantee the ETA is maintained? So, Alex, if you want to start with that, and I can then talk about, how the FileCatalyst, acceleration protocol works in a bit more detail.
Mm-hmm. Okay, so from the networking perspective, it's fairly straightforward. So the way our infrastructure works and the way Schedule works is that once you've been given a connection and a bandwidth, you're guaranteed that bandwidth. So if I'm given 100 megabits or a gigabit or even 10 gigabits across the network, I'm guaranteed that bandwidth. We don't do packet loss in the network. We guarantee that everything that you put into a network service gets out on the other end. So that gives you guys a fairly nice network connection to work with.
Yeah, and since we have that network connection, we don't have to start at a low speed. We basically, the FileTeleport engine tells us what bandwidth has been allocated on the network, and we start transferring at that bandwidth, and we maintain that bandwidth throughout the entire transfer. Since we're immune to latency, we can continuously maximize that link without having to drop off. And since there's no congestion on it, we don't have to play fair on that network. We can just maximize and utilize all the available bandwidth that's been provided on that link. Yeah, so another question's come in. Does FileTeleport support multiple simultaneous destinations using multicast feature of Nimbra MSR? That one's for you, Alex.
Yeah, so there's nothing stopping us from doing doing multiple transfers. Of course, technically, you could look at technologies like multicast, like we have support on the Nimbra MSR platform today. That would break how IP works on top of it for the actual file transfers. And the reason I'm saying that is if you look at the file transfers that we are doing, you're making a file transfer to multiple different destinations, then you run into the questions like, okay, what happens if one destination is unavailable, or if there's less capacity available to one destination, or if there's something wrong with the disk at that destination. So once you wrote the file to disk, you realize that the checksum is not valid. Do you take everything back, or do you leave the file on the destinations where you had a successful transfer? So there's a lot of, I should say, less technical questions that have to be sorted out. There's nothing stopping us from doing it with the platform we have today, but we haven't seen the applications where people have been wanting that so far. But it is a very good question, and there's nothing stopping us from doing that with the platform. So I'd be very happy to discuss that in more detail if there's interest for that.
And there's another one here. Does the FileTeleport work with both into the managed network and outside the managed network with internet connectivity, or is it dedicated to just a managed network?
Yeah, so it works with both. So what you have, if you look at this system and kind of a baseline or basic installation, you would have a managed network within which we do file transfers. You would have an internet connection so that your end users could have an iPad or a desktop application or a web portal connecting into this system requesting file transfer. That would come in through the internet, obviously. If you want to do file transfers over the internet as well, that also has to come in through some kind of gateway to secure it. So as long as we stick within the managed network, we don't need to worry about firewalls, etc., because we are in a controlled environment where nobody gets in and nobody gets out. So you can definitely tie in internet connections to that, as we talked about before. File transfers over the internet would definitely be a complement, and the solution supports doing that. You would typically do that through some kind of gateway to the internet, so that you can have one FileCatalyst instance that is very secure, running your internet-related transports and file transfers, and then you connect that to the broader solution on the managed network. So I guess the shorter answer is yes, you can definitely have internet connections coming into the solution as well.
Cool, thanks. And another question is, can you send multiple jobs at the same time? So yeah, so the FileCatalyst transfer agent can support multiple transfers at the same time. By default, it can it's all based off REST calls, so you can send multiple REST calls to instantiate transfers. In terms of how that's handled from the FileTeleport, I'll let Alex just explain a bit more about that.
Yeah, no, but we don't have any restrictions on that whatsoever. So the end user, if you want to pick 5 files and send that to one destination, and then pick another 5 files and send that to another destination, or the same files or different files, doing it multiple simultaneous transfers to the same destination, all of that is doable. So we're telling the FileCatalyst transfer agent to do those transfers for us to move the files, but we also set up then individual network connections. So what you can do is you can say, these 5 files, I want to move them from A to B, and these are super urgent, so I'll do the as soon as possible modes. I have another 5 files that I want to move to the same destination, but they are not as urgent, so I'll set up a slower connection to do that. So you can actually do parallel transfers between the same 2 endpoints if you have some files that are more urgent than others, etc. And we will set up bandwidth based on that user input. So no restrictions in terms of parallel transfers.
Cool, thanks. Yeah, we got a few more questions coming in. Using Nimbra, one can select the bandwidth. Here it's mentioned as one can choose speed of transfers in FileTeleport. If one opt for a high bandwidth transfer, which speed it adopt, Nimbra tune speed or FileTeleport speed?
So yeah, sorry, something happened with my audio here. Can you hear me now?
Yeah, we can hear you.
Yeah, oh, perfect. Yeah, sorry about that. Yeah, so the user, as a user of this, all I care about is my files and destinations and time of arrival. So what we do is that we look at the file size, and then we calculate how, on the FileCatalyst level, how fast do I need the file transfer to happen. And then there's, of course, certain overhead. So we're setting up an Ethernet connection. We then have IP overhead. FileCatalyst has the protocol sitting on top of UDP as well. So there's a certain bit of overhead on top of the Ethernet connection. So what we're doing is we're taking the file size, we're calculating kind of the good put, so to speak, how much traffic you need to get through over a certain period of time, and then we translate that into Ethernet capacity on the Nimbra MSR. So the user simply cares about the time, and FileTeleport does all of the calculations for them in terms of how fast the underlying connections need to be.
Cool, thanks. And the last question I will be taking, because it looks like we're running out of time, is how can the transfer solution be integrated into a content management system? And have we done this already? If so, which CMS?
So with the solution, we have the FileTeleport backend. And I don't think I mentioned that before, but on top of the backend, we have an API. So the application that the user would be using uses that API to interface the FileTeleport backend. You could connect any media asset management system onto that, or any workflow or orchestration solution on top of that API. Without pointing to any specific vendors, many of the workflow systems on the market and many of the media asset management systems with workflow capabilities can integrate with external APIs and external systems. So what would happen is that the media asset management system sitting on top could drive FileTeleport and say, this file is urgent. I know that based on the metadata I have tied to the file. This is less urgent. I know that based on the metadata. And all of that can drive FileTeleport through that available API. So we don't have any restrictions in terms of what the interface sitting on top of it is, whether that's a user interface on an iPad or a web browser, or if it's a hidden interface driven by more of an automated system. We don't have any, I don't have any names of content management systems or MAM systems that we can officially talk about, but there's definitely no restrictions in terms of which systems you can tie in, as long as they can access an external API to request the transfers to happen. And again, that's one of the things that I would be very happy to talk in detail about if you have specific questions or CMS systems or MAM systems or workflow systems that I would want to tie this into.
Thanks. Well, it looks like that was the last of our questions that we'll be taking today. Alex, thank you very much for joining me on this webinar. You did most of the talking, which was great as well. And thanks to the entire audience for taking the time to be with us today and learn more about the FileTeleport solutions. This webinar has been recorded and it will be available on our website in a few hours, as well as we'll be sharing with Net Insight to place on DR social media as well as their website. If you have any questions regarding this webinar or either technologies, feel free to reach us. We have, contact us or request for trial links on both the sites listed on the page that's in front of you. Otherwise, feel free to, join us on the next webinar, which we'll be having next month. So once again, thank you very much and have yourselves a great holiday. Alex, thank you.
Thank you very much, Elton, and thanks to everybody in the audience. Thank you very much.